section 3.2 is about polynomial functions and their graphs. Polynomial, poly is many, nom is name or term. So it's a function with many terms. Each term is in the form a number times the power of x. So an x to the n plus an minus 1 x to the n minus 1 all the way down to a1 x plus a0. Don't read too much in these subscripts. It's just a way of denoting. There are more than 26 unknown things in the universe, so sometimes we subscript the letters just to give us more leeway in naming things. These a's, a0 through an, are called the coefficients, meaning work with. A0 is the constant term, and if this an is not 0, then this an x to the n is called the leading term, and n is called the polynomial's degree. That leading term governs its long-term behavior. How does p approach plus or minus infinity when x approaches plus or minus infinity? There are four possibilities. A is positive or negative, n is odd or even. If n is odd and a is positive, it goes from negative infinity to positive infinity with some unknown number of wiggles in between. If n is odd and a is negative, then it goes from positive infinity to negative infinity after some wiggles in between. If n is even and an is positive, then it goes from positive infinity back to positive infinity with some wiggles in between. And if n is even and an is negative, then it goes from negative infinity to negative infinity with wiggles in between. Now, we have some equivalent statements about p of n, p of x. One is that p of c equals 0. That is to say, c is a 0 or a root of p. Another is to say that c by 0 is on the graph of y equals p of x, which is to say x equals c is an x-intercept. And the third thing is to say that p of x equals x minus c times some polynomial. So x minus c is a factor of p. So roots and x minus c factors and intercepts on the graph are all one and the same. So for example, if x times x minus 3 times x plus 2 equals 0, then what is x? Here we're finding zeros of the function. Well, either x is 0 or x minus 3 is 0 or x plus 2 is 0, which gives you x is 0 or 3 or negative 2. We can use this long range of behavior, roots and sine graphs, to sketch graphs of factored polynomials. So for example, this one, y equals x times x minus 3 times x plus 2. Yeah, x-intercepts are 0, 3, and negative 2. If you expand it out, y will be x squared, x cubed plus other terms, 1x cubed, a positive number, and an x to an odd power means it goes from negative infinity to positive infinity. If you make a sine graph of it, oh dear, I should put a 3, a 0, and a negative 2, and a 0, 0, 0 here, excuse me. I'm gonna have to rewrite the sine graph, my apologies. Anyway, it's positive above 3, negative between 0 and 3, positive between 0 and negative 2, and negative below negative 2. So the graph will look something like this. Negative, 0, positive, 0, negative, 0, positive, like that. And with a characteristic n-shaped curve of a cubic function. The polynomials will sometimes have turning points, also called local extrema. So here's a graph of y equals x cubed plus 1. Here's the minimum value, and the minimum value is 1 at x equals 0. Here is evidently some kind of cubic. It will have, and this one has a local maximum of y equals 1.5 at x equals negative 1, and local minimum of negative 1.5 at x equals 1. Here we have a graph, up, and down. A local maximum of y equals 3 at x equals negative 3, a local minimum of y equals 1 at x equals 0, and a local maximum of y equals 2 at x equals 2. Now, the degree of a polynomial will show how many roots it might have and how many extreme values it might have. So if it has degree n, then it has up to n roots. So it could have fewer. Has up to n minus 1 extreme values. Again, it could have fewer. For example, here's a degree 3 polynomial with 1, 2, 3 roots. and only one root here as they kind of get stretched out and two of the roots disappear. Here it has 1, 2 extreme values. Here it has no extreme values. If you have degree 4, with therefore 4 roots, and in this case 3 extrema, 1, 2, 3. But here's another degree 4 equation, which polynomial, 2 of the roots disappeared. It has only 2 roots, but it still has 3 extrema. And if we lift it up a bit more and straighten it out a bit more, here's a polynomial with no roots and 1 extreme value. There's something called the intermediate value theorem, which says that if P of X is a polynomial and P of A and P of B have opposite sign, then P of C equals 0 for some value C between A and B. So in other words, we can't go from negative to positive or positive to negative without going through 0. This is true for all polynomials, and it's true for a whole class of functions called continuous. Well, we'll say more about that. A continuous includes polynomials and sines and cosines and exponentials, but not reciprocals because it's discontinuous at 0. Sometimes a root can happen more than once. If it has a factor x minus c to the n, then this m is called the root multiplicity of the root c. So, and this will change the shape of the graph. If m is odd, then it'll go from negative to positive or positive to negative, pausing for a moment. That's C. If m is even, it'll be like a graph of x squared, which it skims the axis. Here it goes from positive to positive and 0 for the briefest moment. Here it's going from negative to negative, and here it's 0 at just one instant. So for example, graph y equals negative of 2x minus 1 times x plus 1 times x plus 3. Now, if you multiply it all out, you get negative 2x cubed plus lower terms. X cubed means it goes from negative 2 times an x to an odd power, means it goes from positive infinity to minus infinity, with some wiggles in between. For the intercepts, well, y equals 0 when 2x minus 1 equals 0, or x plus 1 is 0, or x plus 3 is 0. This will be true if x equals a half, or negative 1, or negative 3. These are the roots, these are the intercepts. If you do the sine graph, and I did the sine graph correctly this time, negative 3, negative 1, 1/2, it's 0 at those values, negative to positive to negative to positive. So positive to 0 to negative to 0 to positive to 0 to negative. The x-intercepts are at negative 3, negative 1 and 1/2. The y-intercept, well, you just plug it in here and get y equals 3. Here they ask the factor, find roots in graph. X cubed minus x squared minus 6x. Because it's a 1x cubed, it goes from negative infinity to plus infinity. All right. Now let's start factoring it. Here's a common factor of x comes out. P equals x times x squared minus 6x minus 6. Then using usual PQ method for this quadratic, that factors into x minus 3 times x plus 2. So P equals x times x minus 3 times x plus 2. All right. It's 0 when x is 0, or x minus 3 is 0, which means x is 3, or x plus 2 is 0, which means that x is negative 2. So you draw a sine graph, then x is negative 2 or 0 or 3, y is 0. It goes from negative to positive to negative to positive. So negative 0, positive 0, negative 0, positive. So the x-intercepts are at negative 2, 0, and 3. And for the y-intercept, you just plug in x equals 0 and get y equals 0. And again, I encourage you to use a graphing calculator to get an accurate view of the graph, just so that you and the machine can supplement each other. Here we have find factors, roots, and graphs of P of x equals x cubed plus x squared minus x minus 1. Because it's a 1 times x to the third, it goes from negative infinity to positive infinity. All right, I can start factoring easily enough. These first two terms have a factor of x squared times an x plus 1. These two terms have a common factor of negative 1 times an x plus 1. Pull out this common factor of x plus 1 times an x squared minus 1. And this is a difference of x squared minus 1 squared. And difference of squared is a difference times sum. So you get x minus 1 times x plus 1 times x plus 1. So, oh, we have a multiplicity 2 root. So the roots are at when x equals 1, x minus 1 is 0, when x equals 1. When x plus 1 is 0, or x equals negative 1. And furthermore, this negative 1 is a double root. If you draw a sine graph, it goes from negative to 0 back to negative to 0 to positive. Negative to 0 to negative to 0 to positive. And the x-intercepts are negative 1 and positive 1. And plugging in x equals 0, you get that the y-intercept is negative 1. Here they just give you a graph. Actually, they give you, in the book, they give you an equation and its graph, and then say find its extreme intercepts, which is silly because here's the graph. You can just read it off. The x-intercepts, all right, x equals negative 2 and x equals 1. The y-intercept is at y equals negative 1. And this is a local minimum. Oh, you know, I should have added 12 maximum. Okay, the minimum value of y is at negative 2 at x equals negative 1. And I forgot to mention, and we'll put on the Canvas site, that the maximum, a local maximum, is y equals 0 at x equals positive 1. Okay, I have some changes to make.